Hey, welcome to Cloud and Sack. In this video, I want to talk about Entra Private Access. This is an exciting new capability within the Microsoft Entra family, one that has been announced over the last few months. It is an exciting feature as we're going to dive a little deeper into some of its main capabilities, but it's exciting given how much it centers its security around identity. It's an identity-centric way to give your users access to your sensitive resources on premises. This is extremely valuable in every conversation I have with my customers and something that is top of mind for every organization that has legacy applications and even very common administration applications on premises running on top of network protocols such as RDP and SSH. So let's have a look at what Entra Private Access is, and I'll have a look at a quick demo. Okay, let's start from the top. What is Microsoft Entra? Entra is a family of products that look at identity and access to your corporate data and secure access to your corporate data through different means. Now, in Microsoft's own webpage for Entra, which I have on screen right now, public information naturally, as you scroll down, you can see here and over here you can see the use cases for the Entra family of products. Some of them are secure access, others are specifically targeting identity protection, other looks at access verification, and even user experience from a business to consumer or to consumer client use case. What I do like about this page is this image right here. Zoom out a little bit, you can see it even better how we have essentially three categories of products within the Entra family of products. We have for identity and access management IAM solutions, we have Entra ID, which used to be called Azure Active Directory until a few months ago. We have Entra ID governance, Entra external ID, and these are the products for it. Now, there are new identity categories that are into the Entra family, such as Verified ID, which is part of Verified Credentials, which is a new stream of B2C solutions that are very prominent in very large markets, but also very specific use cases for retail and even public organizations that need to provide verified credentials from its users or even population. And then we have Entra Permissions Management, which is a KIM, Cloud Infrastructure Entitlement Management solution, and Entra Workload ID, which targets workload protection, workload identity protection, and its related information. Lastly, under network access, we have the family of products, or the couple of products that I will be focusing here, which is Entra Internet Access for all access to your Microsoft and cloud applications, and Entra Private Access, which is the topic of today's video over here, and Entra Private Access being your way to secure connections to your private applications. If I go into the specific page for Entra Private Access, which is this one right here you're seeing on screen, we can see its specific use cases mostly around proper segmentation of your data back to your controlled applications, utilizing a zero trust network access kind of methodology to gain access to your network instead of relying on traditional flat networks or traditional subnets that give access to every single resource within particular subnets. Critical to the center here, you can see the use case for conditional access controls, which in my opinion it's the main goal or one of the highlights of this solution, right? Private access from some of these use cases and how it's implemented, and even the technologies that we're deploying when we're setting it all up, is actually very reliant on a lot of the capabilities that have been available through Azure Application Proxy, which has been technology that's been around for years now. So it is very similar to that, but this encompasses all of these capabilities and is looking to enhance even further some of the capabilities that have been available to Microsoft customers for a little while there. Now, this here is an identity-centric solution, like I'm saying, and these here are the capabilities or some of the capabilities, but like I'm saying, it focuses on zero trust, focuses on not needing to provide legacy ways to your internal applications via VPNs that otherwise would provide you with network access instead of identity-centric network access. And it will also allow you to provide some specific use cases for adaptive per application access that is granular down to the user level, and also can apply very granular conditional access policies based on whatever conditions you may want, leveraging Entra ID, naturally. So this is the 3-minute overview of what Entra actually means and where Entra private access falls under. Now what I would like to do is to have a look at the portal of the solution and a quick diagram of a lab I set up for a quick demonstration for this video. So let's have a look at the dashboard of the solution. All right, so here we are in the Entra portal. So one of the benefits of having this Entra family of products is having all of these kind of solutions that I mentioned before within the same dashboard. So within entra.microsoft.com. So it helps your identity teams and whoever needs to have access to these kind of solutions to have access to all the required information from this portal. Now, within the left-hand side here in the menu, we can see the many different domains that Entra can look at. So within identity, we're talking about Entra identity. Within protection, Entra identity, but protection mechanisms and potential policies that we can create. Governance for Entra governance, ID governance, verified credentials for verified ID, and so on and so forth, until we get to global secure access, which is the blade that includes all the required steps for us to configure and monitor Entra private access and Entra internet access. Okay, so that's important. Everything for Entra network access is inside this menu here. What I want to focus on here today is, of course, getting started with the solution. What do you need to do, right? And why would you need to use Global Secure Access Blade here to get started? Now, under the Get Started page, you can find the official Learn documentation, which is very helpful. I would advise you have a look at that if you need to dive deeper into the solution, and when, of course, you're setting it all up so that you can see the fine print of details and prerequisites. That's all very important because this is a preview capability, some of it. So it's important that you understand what's supported, what's not supported, when some of the documentation even states what's coming next, particularly around the support for wider operating systems, for example, and other ways to deploy connectors, for example. This is called out in the documentation. That's why I highly recommend you oversee and review the documentation for it. Now, within the solution itself, what I want to look at here is how to set it up. So first thing we're going to need is, and let me jump into my architecture, because then I can flick between my architecture and how to set it all up. Let me do that. Okay, so this here is my current lab architecture. It's all set up in Azure. It's a very high level diagram. It doesn't get into the network's security groups or into the virtual nets details, only really what's needed for me to explain where I'm at currently in my lab. But essentially what I'm trying to do here and what I'm exemplifying is a user on a different subnet or a different VNet, in my particular case, trying to access the local servers or a server that only has local access to a different subnet. Okay? So my example is this particular user here called Link wants to access an RDP server or a web server and even a Linux server that they don't have public IP addresses, right? So they cannot be accessed from outside that VNet regularly. So how do we do that? With Entra private access, we can set up what we call the connector server, or there is a connector piece of code that we can deploy to a Windows server currently, and that essentially enables that particular subnet or whatever servers that you define in the rules in the portal. We're gonna go have a look at that soon, but whatever rule IP addresses and ports you define in there, that this server has direct line of sight to be accessible from what we call the global secure access client devices. Okay, so that's very important. It's a very easy way to set up your virtual private channel, if you will, for access to those particular resources. So the first thing we have to do here then is to, of course, deploy the connector and then set up what applications this connector has access to. Okay? After that, we're gonna set up the policies for these applications, that we set up before. That's the third step, set up the applications here, the policies. Lastly, we can deploy the client to the devices. So it's a very straightforward kind of scenario, and also very straightforward steps for us. All right, so jumping into the dashboard, where can we download the connector for my server? First thing we need to do then is to come into the global secure access and then under connect. Okay, first thing I want to do and I would recommend is to enable traffic forwarding. This can be done at a later stage, but I want to do it first since it's the first here on the list. Just enable private access profile. This means that whatever connectors are connected here are sending private access information and connecting to a private channel for access to applications that you set up in here. So just enable that checkbox. Secondly, let's look at the connectors. So on the connectors page, you can see that we have connector groups. Connector groups are separation and segregation of what applications can be accessed from specific groups of connectors and how you set them up. So what you need to do here, and I've already deployed a couple here, as you can see, and you can see their status and their IP addresses, which I'm going to need to clean later on in my editing. But then, of course, what we need to do is just click on download connector service. It gives you the prereqs here, highlights the prereqs, but also at the end it has the download link. The download link is something you can just copy, and I've done that in my lab for an easy deployment. To just download the link, just copy the link itself, paste it into your servers remotely or however you want to paste that link, and then of course you can download directly from that server. So that helps you just have an easier access to download that connector to your connector server. Okay, so remember that, the connector server. So if I go back to my architecture, what I've done is I jumped to this server right here. This is accessible publicly, absolutely, and I downloaded the connector there. After that, a couple minutes will take in, and then it'll be active here. Upon the installation on that server, you will be asked by an authentication. So you'll need to authenticate to an account that has access to that particular service and that is a proper administrator for that particular organization environment. Okay, so next up, what we need to do is set up the applications. So we can create enterprise applications like what we do in Azure, and this can be fully customized like what you can do with them. But for easy access and for easy setup, they've given us access to what they call quick access. So quick access right here is something we can, essentially we have an enterprise application that's a template for us. It already has the name here. We can just modify to what we want. We can state where this application or how this application is going to be accessed by. So this connector group here is an information that you need to link up with the group that you chose when you deployed your connector group. You can move them around. You can choose the connector group here very easily. It's all pretty much seamless. Policies are pushed out very frequently, so you won't have access modifying them for your testing purposes at all here, right? So it's very easy to just modify them as you need. And then at the bottom here, you need to add application segments. These are effectively your applications and the protocols that they are accessed through. In my particular use case, if we go back to my diagram, I have two servers. I have one server here sitting on a particular IP address which ends on .5. This is a Windows server right here, and it runs on RDP, so I need to allow RDP access to it, so port 3389, and it also runs a web server that I don't have the certificate for, so I just set up a port 80 for a quick example. Next up, I have another virtual machine that's running Linux. That is on a different IP address that ends on .6 in my virtual net, and it requires, and I would require access via SSH port 22. So this is how it's set up. So you just need to inform what IP addresses, where you have applications sitting behind IP addresses, and then you set up the ports. So as you can see, you can create a list of multiple ports behind an IP address by just utilizing the comma notation. And then I set up a second application that can be accessed through this particular application here, or virtual application, or quick access configuration for port SSH, right? Port 22. The next step is to give people access to this quick access configuration or quick access application. We do that by clicking on the Edit Application Settings button here at the top. So I'm just clicking on it. And as I do so, you can see here under users and groups, this is the first thing you need to do. Just give your users access, or the required users naturally that must have access to those applications, access here to this blade. So just click on add user and group, choose the required users or groups of users that need to be given access to those particular resources. In my example, those are on-premises or so-called on-premise administrative applications, so they could be, and they should be most likely only accessible by administrators or IT or security personnel. So you'd likely already have groups of those manners in your Entra ID architecture, and so you just choose the required groups that contains all the people that must have access to those particular applications. Under network access properties, we're going to see the same information that we had seen before. Okay, so it's the same information. So again, the backend or the backbone of this entire operation is very similar to the Azure application proxy solution that we also have access within Azure. So it's the same technologies essentially, but this done through here is just a little more cohesive for whoever needs to deal with identity access to particular applications. And as I said before, for the future, there will be particular features focused on zero trust network access that will be rolled out to these blades and global secure access domain here for us to maintain and manage. And Azure Application Proxy will continue to exist as well, naturally. Okay, cool. So under conditional access is where we can create conditional access on how people must authenticate in order to access the services that we are allowing through this enterprise application here, or this quick access application that I create, or that the platform created for me. Again, one of the main benefits of deploying zero trust through an identity-centric solution such as this, right? So if I head over to one of them, I can see it's your regular conditional access policies. So you can see the users that apply to these particular policies, the target resources, the conditions, and the access controls, whether you want to grant or block access to whatever parameters you chose beforehand. So very helpful. If you choose to perform MFA under the right conditions, you will get prompts, or a user will get prompts, and for them it'll be transparent, right? They don't have to worry about going to a particular web page in order to gain access before, or logging in somewhere to the VPN in order to get particular access to something. For the user that has the global secure access client set up on their device, and I'm going to show that in a few minutes, it's transparent. The client just runs on the back end, connects to the private channel that they must have access to, and whenever they require access to these resources, the conditional access policies kicks in and verifies in real time. So following the tenets of zero trust, one of which includes verify explicitly, right? So this is the overview information that you need to have a look at when you're setting up your quick access application here. Once you've chosen the applications, you've selected the IP addresses and ports, and you've given access to your users and checked whether you want or not conditional access policies enforced on top of all of them, The next step is to look at your end user devices and how they're connecting back to your private channel. To do that, we have to come into devices and clients. Very straightforward. Just download the client into your end user devices, push that out however you want. And it says here that the client is currently only available for Windows, and all their client versions will be coming in the next few months. So just be mindful of that. So once you download the client, essentially you're all done. There's nothing else to do from this perspective. Now what I want to do is jump into my lab environment and my virtual machines. So let's do that. Okay, so for this particular example, I have publicly accessible 2 virtual machines. The third virtual machine I haven't operationalized yet, so we're not going to use the Zelda Windows 11 machine, right? We're only going to use my user, which is the Link virtual machine, as you can see here, and we're only going to use the server as well. I'll start off by reviewing the server information first. So let me just jump into the server. Within the server, you can see here that the server IP address is within the subnet 10.1, for example. I can also verify that this is my connector server. I put in the required information here to exemplify such. But I can also see that this particular server has a remote, an RDP connection to the RDP server that I set up before. That RDP server is not publicly accessible. It's only accessible through the same subnet, okay? Very straightforward, very important to note that. So if I close this virtual machine here and I attempt to log in again to this very own IP address, which is on the same subnet, I will get access straight away, right? Very straightforward. If I attempt to SSH into my Linux, I will get prompted by the password after a couple seconds there. Okay, my server is up, but for whatever reason I'm not getting an SSH response. I won't worry about that. That's all good. I can showcase the RDP and the AD or web server access remotely. This is a look at from my server within the .1 subnet back to this other device running a web server here. So this is a local page running on a locally accessible server only. This is web page that's not publicly available, and my local IP address is this here. So that's all good. This is the local IP address of that server running that web page or serving this page, right? So if I come in here and I run the IP config of the machine that I'm connected from, it's a different IP address there. It's .4. For this server, I have deployed the connector, right? So we can verify the connector by going into the services. And once you install the connector, what you're going to be able to see is mention of this here, which is the Microsoft AAD application proxy connector running on the server. Okay, so that's very straightforward. Once you see those 2 services running and you have authenticated properly during installation, you're going to see the setup installed properly, and that's all you need to do. Next up, that's all you need to do on the server side. Next up, let's have a look at my client. So this here is my client, and I could, this is the whole end user device for my Link user, for example. Now, from this perspective, what I've done here is run a pconfig so that you can see it's a different IP address. It does not have access to that particular device that I mentioned before, which is the web server. So if I try to ping it, it doesn't have ICMP access to it. It doesn't have necessarily direct access, only the RDP and SSH, or RDP and AD access to it. And for my Linux server, it does have SSH access to it. So if I attempted to run SSH to my Linux server and the Linux server was responding to SSH, I would get access to it. I just don't think it's going to happen here. because there's probably something wrong with the server, and that's all good. What I want to showcase though here is what's running in this device. So if I look into the running applications, you can see my, my face is in front of it, but there's what we call the Global Secure Access Client in it. This is the menu for it. You can see I can switch users, so I'm prompted for new authentication for that. I can pause, resume, restart. I can run a client checker. So I want to show you the client checker here. It's a command line that makes some basic diagnostics on top of what's going on in that particular client. And it just tells you for troubleshooting purposes whether everything is running fine or not. As you can see in my example, everything is running fine. Perfect. That's good. What's really important here for us is the last two, private channel reachable. This means it has access to the connector, to a connector that is serving a private tunnel to it. So that's really what I need to do in order to connect this machine back to some of the applications behind that connector. Next up, I want to showcase you the GUI for it. So if I right click this device and I click on connection diagnostics, I get this GUI interface. So it's just an easier way for users and even for level 1 troubleshooting engineers and help desk to have a look at what's going on from their perspective to that client. So I can see here the flows that are running in this device and this machine, the source IP, the destination, and I can verify whether the flow is active or inactive, but also the channel name here at the very last column here. And also even what kind of destination ports are actually going to and from here. Under services, I can see what Entra private access services are available here from this client, but the most important part is channels. I can see here that I have private, and it currently utilizes a green and red icon, so you can see it's green here. My opinion, it's not the most accessible way to represent if something's working or not, so hopefully we'll get something else there in terms of informing more clearly, perhaps with text as well, that private channel is working fine. And that is the case. So from this machine, I do have access to this private tunnel. So my next step is then to start testing from this client if I want to access that RDP server running on a very different subnet. So my experience as a user is just attempt to connect or to access those resources regularly as you would, right? So again, no VPN to connect, and there's nothing else to connect from user perspective. Just have the client running properly with a private channel ticked on, and yeah, that's it. So just use services as you would normally. If I click on connect here, I'm gonna initiate and start configuring the remote session straight away, and then I'm gonna be prompted for my authentication, which I'm being right now. And I just enter my password, and I do want to validate that yes indeed from this client machine I can access a remote server as I intended. So right now you can see me here. If I clear my, oh, there you go, it's asking for my password. Took a long time, but there you go. I'm finally asked from that Linux server for my password. Okay, so I'm gonna make a pause in my RDP demo just to call out that yes, the SSH connection is working properly. It's just taking a long time there for whatever reason, whatever's going on in that Linux box that has less compute power than likely your Apple Watch, I would say. Okay, but anyway, what I want to showcase here is once again highlight the IP address from this machine. So this machine is running on subnet 0.5, and you can see it's a /24 subnet, right? It's yeah, 255.255.255.0. So that is a very different subnet from what this server is connected to. Okay. Now next up, what's only left for us to test is a web connection to that server. And yes, indeed, I'm just refreshing it here. Indeed, I do have access through port 80 to that server. And again, This is what it looks like. Same page that you'd have seen from the server when I connected earlier. If I open up the GUI from my client, the Global Secure Access client, and I open up flows, all throughout those new requests, you would have seen here updates in real time happen, and you can see here destination ports being 80, being 3389, so everything happening live here, and everything shown to you from a troubleshooting perspective. It's very helpful. So with that, I've showcased how Entra Private Access and its easy deployment can help you set up an internet accessible resources to your on-premise applications, and securely following the conditional access policies or whatever policies you require in your organization. So hopefully you found this useful and this information relevant to you. If you did, leave a like, drop a subscribe, or do the subscribe. Just click on the red button there if you find it useful. I did have fun coming up with this lab. Took me hours, but it's good because I've been able to talk about this solution to a couple customers already, and this solution is topical, like I said, to any organizations still relying on on-premise applications. And well, every organization will have those. So how do we keep accessing them in a secure manner? That's the point. And this is how. Okay, till next time, and leave a comment if you found it useful. Cheers, bye.